Bryan, you're going to do, I think, wait.
Speed this up. So yeah, thank you guys for showing up. I know it's unusually chilly out tonight. So yeah, Night with Docker. So last October, we had our Docker 101 presentation and just going from zero to not hero, but covering the basic concepts. And this slide was towards the end of that presentation, and this was next possible areas that we wanted to explore for this meeting. So we unfortunately won't be able to cover everything on this list. We're not going to get to Swarm or continuous integration and delivery, even though I would love to do that in a container context. But we will touch on volumes tonight. We'll talk about the Docker file, and we'll talk about Docker Compose as well as Docker networking. So that's the high-level agenda for tonight. And again, I think this was built as a Docker 201. It's really a continuation of 101. So that being said, we're not going to cover all the same ground that we did a year ago, but this is just a refresher for anybody that's still a little rusty. So containers, what are they for? They're isolated processing environments to include their own network storage, CPU, house on, so you can have multiple containers sharing the same host system. And the idea is to try to include as much as you can inside a given container system. So your operating system, files, dependencies. You probably can't get everything in there, as we'll talk about later. And they're meant to be lightweight, so you can spin containers up quickly, spin them down quickly, just as easily. So some high-level use cases, areas where you'd like to see containers used, deployments. So the idea is if you can run a containerized application on a developer's machine, you should be able to take that same containerized application, run it in a QA machine, UAT machine, stage, prod. In production, you're able to usually fit more containers on a given machine to increase the utilization of your hardware, so it's great for efficient production environments. And for development, even though the canonical container use case isn't to be a full-blown development environment, containers are great for sandboxing, just kind of getting your hands on different pieces of software. They're really easy to spin up and just kind of noodle around a bit. And I think as we go forward, we're starting to see containers be used more as true development environments, but I'm not a developer, so I can't really speak authoritatively on that. And so what is Docker? Docker is not synonymous with containers. It's software that makes containers easier to use. Their motto, which I'm assuming it still is build, ship, run any app anywhere. So similar to the Java mantra of write once, run anywhere. They're doing the same thing for containers. So the name Docker is derived from dock worker. Back in the day, shipping industry before the advent of standardized container units, you had dock workers who were paid handsomely for their ability to munge different goods onto ships and to really try to get the maximum uses out of a ship's capacity. Well, with the advent of standardized container dimensions, the dock worker's skill set was no longer in need. And so if you had a ship and you knew that, okay, I've got a ship of certain dimensions, and I know we've got potential standard container sizes that can be on said ship, it makes life a lot easier as far as getting cargo to and from. And so as long as you could put your rugs or your vases, fit those inside a shipping container, it would ship. And so that's kind of the deal with Docker software. As long as your application runs inside this, fits inside this Docker container, it should be able to ship anywhere. And again, Docker is not the beginning of containers, and it leverages several key Linux technologies, two being the kernel namespaces, which creates the isolation for your container environments, and control groups. So even if you've got logically isolated groups on your machine, everything is still sharing the same resources. So control groups are a good way to limit resource usage to make sure there are no bad actors hogging all the CPU or disk I/O. And the final refresh slide, these were the core concepts that we touched on. The Docker engine is where a lot of the heavy lifting happens. Usually you'll interact with Docker via the CLI, which is what you'll see tonight. There's also an API you can use. Docker images are the binaries in the Docker world. Think of them as blueprints for containers. Containers are your actual running applications, so you could think of those as like your deployment artifacts. And your Docker files are your source code essentially for image creation. And registries are essentially repositories for images. And so that's the refresh. If anybody has questions regarding basic container stuff, feel free to chime in. You know, we just didn't want to do another one-on-one presentation, but we're definitely willing to backfill. And also along those lines, I'm definitely not a Docker expert. I know, Sebastian, you work with Docker a bit at work, but you know, this presentation is more of a guided discussion. I see a lot of familiar faces, so you guys kind of know how it is. If you got questions or thoughts, definitely just chime in, or if you hear something that doesn't sound right, definitely chime in, because I know, if I speak for myself, definitely, it'll probably be a benefit to me. So, but yeah, let's get started on the presentation. So Docker files. These are the recipes for building your images. There are instructions or different commands in just a file. And the idea is that your first instruction in a Docker file specifies the base image that you want to start to build the rest of your image from. And each line in a Docker file corresponds to a different layer in an image. So an image is essentially a stack of different read-only layers stacked on top of each other. And this slide doesn't really come through great, but the idea is that, I guess I don't have cursor on there, shoot. Okay, so each line of the Docker file will correspond to one layer in an image. So this Docker file sample has 7 different new lines, and there will be 7 layers in this image when it runs. There are some syntactical rules to a Docker file. I believe it needs to be named Docker file, and I believe that's case sensitive, one word, capital D. Again, I'm not 100% sure, but every example I came across while doing the research for this and everything I use is Docker file.
It's the default unless you pass a flag to tell it to use a different file.
All right, well, that'll be the next slide
Yeah,
when we talk about,
so.
okay, right on. So Docker file, no extension, and I guess maybe that you can probably change that if you want. And so each line in a Docker file needs to begin with a reserved keyword. And so Docker provides 16 or 17 different keywords for your Docker file usage. Every line in the Docker file needs to start with one of those keywords. Again, you must include a from keyword, that's a reserved keyword, and that needs to happen usually at your very first line. Sometimes it could be your second line. And your Docker file must end with the command keyword or the entry point keyword. And either or, then you can actually use both. And those keywords let the container knows what it needs to do at runtime when it spins up. So without that, the Docker file will crap out on you. So the idea, so you have a Docker file, you've filled it out, syntactically it's correct, and now you want to actually create an image, and that's where the Docker build command comes into play. So it's essentially just Docker build, and then you pass in the location of your Docker file. Usually, you will run the Docker command in the same location that your Docker file exists, and so if you do that, you can just write Docker build and then period is for the current working directory. If for whatever reason you're running your Docker build command in a different location from your Docker file, to Sebastian's point, you can pass the F flag and actually not just pass to the location of the Docker file, but actually, I guess, include the Docker file name itself, and I guess that's how you would rename the Docker file.
Yeah, and I think it has to be relative. I don't actually know if you can pass
an absolute.
An absolute, or if that has to be. But normally, like, some of my projects have like a couple, like we have one for prod and one for dev. So the prod build is like dockerfile.prod, and dev build is dockerfile.dev or whatever it happens to be. So.
Okay. So yeah, so when you build an image, if you just were to run this Docker build period command, you'll have an image, and they'll have an image ID, and the ID will be, I think, some kind of random alphanumeric thing. And you can reference the image by that, but you can make life easier by tagging your images with a human-friendly name, and so that's where you can pass a T flag into your Docker build command, and you can do that. And so that's a command like that would build an image with the name, image name, and some kind of tag. So build context is a concept that's pretty important when you're dealing with Docker files. So where your Docker file lives on your system, any file or directory at that level or lower on the system becomes part of the build context. And what happens is when you run the Docker build command, one of the first things that happen is that all those artifacts are actually shipped over to the Docker daemon. And again, that's where a lot of the heavy lifting happens. And what's happening is that you're saying, hey, here are all these files or directories that may or may not be necessary to create this image. We're just going to ship them all to the Diamond just in case. Even if the image doesn't use anything, that process of shipping over all of those artifacts to the Diamond will happen. And that can get pretty hairy depending on where you place your Docker file. So if you place your Docker file in the root directory, you literally will be copying your entire hard drive over to the Docker Diamond, and that can take some, time to do, especially if you don't necessarily need it. So build context is very important, and it's necessary because if you want to access the files in your Docker file, they need to be part of the build context. There's a concept of a Docker ignore file, which is just like a git ignore, so you can include that. You create the Docker ignore file at the same level of your Docker file, and you, inside the Docker ignore file, specify which files or directories you want to ignore. And we'll see an example of that, I guess, now. All right, let's see. So is this font size, is that working for everybody? That's good. Cool. All right. So I have some Docker files already created, and these are pretty basic Docker files, just kind of to illustrate some principles. So here we've got from Ubuntu latest, so that's going to be the base image that we use, and literally just running the command to say echo hello world. Yeah. Let's see, 24. There we go. All right. And so, again, it's just as simple as running sudo. Well, I'm using sudo here because I don't have user permissions set up properly, but you see here we're just simply running. And so now that's what we did to create a image. It's obviously a very basic image. You see the different steps, got 2 steps corresponding to each line in that Docker file. You see removing intermediate containers, and you don't necessarily need a Docker file to create images. What you can do is you could spin up a container from an image, tunnel into that container, make your changes, and then commit that container, and that will create an image. But that's not the recommended way of doing that. Big benefit of using a Docker file is you have a source code artifact that you can put in source control. And it's great for documentation, just knowing what exactly resides in the image. So, but yeah, you see this is kind of what the Docker file and Docker build is doing.
Do you have that reversed, Brian? It's put in the, I don't know if anybody can see, it's like all the way at the bottom of it.
Nah, I think this does weird stuff. I think it'll ultimately go back up, I hope. Let's see what happens here. Yeah. So, and here's the new image that we created again. It's just got this funky image ID. There's no tags associated with it. And if we wanted to, oh, we got something funky there. Oh, yeah. And then if I want to actually spin up a container, I can run sudo docker run, and I think I'll need to reference the image ID. I think I can do just that, and it should work, I hope. Yeah, so spun up a container, and that's one cool thing. If you're referencing the image IDs, you don't necessarily need the entire ID. You just need enough to where Docker knows, which image you're referring to. And this was a very simple container. If we go out, use Docker PS, we see there's no containers that are running, but if we pass in the A flag, we'll see we've got a new container that just exited a few seconds ago. That's us. Nope. All right. So the name that was given, even though we didn't give the container a name, It's given wizardly swirls. I guess what Docker does is for any unnamed container, it'll give it some kind of adjective and a famous scientist's last name. So I don't know who Swirls is, but it's somebody, I guess, did great things. Anyway, so yeah. So we spun up a very basic container with that. Like I said, it'd be better to actually tag the image. So this command here is the exact same that we just ran, except now we're passing that T flag, giving the image a name. We're giving it a tag, a demo. Again, we're using the period to represent the current working directory, and we spin that up. And you see here, we're doing some stuff with the Ubuntu latest base image, and you see on step 2, we're using the cache, and Docker's great for that, for reusing your code. So if you're gonna reuse images and you haven't made changes to certain layers, Docker won't redo everything. It'll just say, okay, I see that this has already been done. Let me just use what's out there on the system, which is great for resource usage as well as for performance. Obviously not for containers this small, but and so then if we were to go out and look at our images, we see now we have first copy, demo, and then we can spin up a container somewhere. Yeah, right here. With that. And then I'll run in the same deal. And if we go sudo docker PSA, we see now we have the 2 containers. What the hell happened? Oh, I didn't name the container. Yeah, so Flamboyant Ramanujan, so another famous scientist. And so, yeah, those are a couple of basic examples. With respect to the build context that I was talking about, let's see, let's create another image in this same directory, and we will tag that with the name context and the good tag. And again, we're using that cache, so that's great. Let's see. Show Docker images. We noticed that, oh wait. Okay, so sending the build context to the Docker daemon, only a little more than 2 kilobytes of data is going, which is great. That's super small, and that's because there's not really much happening in this build. We pretty much is just this Docker file, and that's it. There's nothing underneath it, and that's fantastic. If we were to venture out from our safety of our Docker directory, I was just trying to find some kind of location. This is an Ubuntu box. Just trying to find some kind of location where there's more happening. So I found the, I guess, manual folder. And you see there's just more stuff happening here. And we've got a Docker file out here already that's been seeded. And it's the exact same thing, just like the other Docker file. I don't know why it does this whenever I go into Nano and come back out, everything disappears.
It's just weird that.
It's weird. So remember the last time that we ran the Docker build, the build context said that we were sending about a little more than 2 kilobytes of data to the Docker daemon. Here, we're now sending 16, almost 17 megs, and it's because we've just got a bunch more files that we're sending over to the daemon. We're still using the cache, so that's nice, but yeah, that's no good. So unless we really thought we needed these files, this probably isn't a great use of our time. But what we can do is we can create a Docker ignore file. So again, we need to place that in the same level of our Docker file. So we'll just do that here. And inside the Docker file, or Docker ignore file, we have 2 different commands. So the way it works is, well, just like git ignore, I guess. Stars, I'm saying, hey, ignore everything, in this build context, which doesn't make a lot of sense, but that's that. But then we can use the exclamation point to say, okay, also include something. And so I essentially am saying I want to exclude everything from the build context except for stuff that lives in the man6 directory. And if we were to run Same build command. So now instead of the 16 megabytes, we're only sending 5 kilobytes to the Docker daemon, which is much better than what we just did. And just, so that's not really that big of a deal, but if we were to go out to the root directory and we got a Docker file out here, and again, it's the exact same Docker file. If we try to do this, it's going to be definitely different. And so again, what we're doing is we're sending everything to the Docker daemon. And I don't really know how much data this is because this always kind of locks up. And so at this point, I open up a new terminal. Oh shit, I gotta Control C out of it. There we go. All right. All right, so we're back. Yeah, I thought I screwed something up there. So yeah, context is important. Just showing you some of those examples there. So the reserve words, again, Docker provides about 16 to 17 different keywords that you need to use in your Docker file. From being the big one, you got to start with from. So you start with some kind of base image. You can't just create an image from the ether. Command, again, is another required one, that or entry point. So actually, I should have reversed that. Entry point, the idea there is to provide an executable that you want your container to run. So you can do that with entry point. And then command is a way for you to provide default parameters for a given executable. Again, you don't need entry point. You can just run command by itself, as we just did with the Docker files that I showed you. But those three are the only three keywords that are required for a given Docker file. Run allows you to run commands in a different layer, and we'll see an example of that. Some others, copy and add, those are obviously pretty self-explanatory. Able to copy files from a host to an image, which ultimately will reside in a container. I think add, though, allows you to tarball extract, and also if you need to access a file on via a remote URL, you need to use add. But I believe copy is the recommended method if you want to copy files from your host system into an image. That's what Docker recommends. Work directory, you can set the working directory for the commands listed below, those reserve words. And you can have multiple working directory commands if you want to change it up throughout the course of your Docker file. And then expose, if you got a container that you ultimately want to have available ports to, you can expose which port a container listens on, and we'll see an example of that. Oh, I guess here. Is that really? Shit, all right. Oh, okay. So here we've got a little more beefy Docker file. We're essentially installing Nginx on here. Again, we're going to just use the Ubuntu latest image and send user root. I got this example off the web, so I don't really think anything's really happening with this user root, but we could set this to a different user if need be. Here are some of those run commands, and I'm sure you guys are all familiar with what's happening here. We're updating. We're going to actually install Nginx here. We're going to remove some of the default Nginx configuration file, because here we're going to use copy to actually copy the Nginx configuration file from our host system, and we're going to place that into the image / container at this location. Same deal with copy. We got web directory on our host system, and we're going to copy that contents over to these two locations inside the container. And then we're running this command here. I'm not sure exactly what the purpose is, but I didn't want to chop it. And then here we have the expose keyword. We're going to expose port 80 for Nginx. This doesn't actually do the port mapping that happens at container runtime, but this is the internal port that the container is listening on. And we have to finish up with the command or entry point keyword. And so we want to start Nginx whenever the container actually starts. That's what we want to have happen. And so we have this, here's our Nginx configuration file. We have this web directory with a very, very basic web page in here. And we have a CSS file. So the idea is, well, we'll actually spin up a quick website. So we're going to tag our new image Nginx test. You see a little more is happening. Just who here actually has experience working with Docker files? So, yeah, keep me honest. If I'm just making shit up, definitely call me out. It's like, right. When I signed up for this presentation, at the time I was actually working with Docker a bit at work, and I guess that was earlier this year, and that stopped happening. It's been all Terraform and Packer for the last 6 months. So so my knowledge is pretty much what I've done to get ready for this presentation. So yeah, definitely, keep me honest. Let's see here. So yeah, you see many more steps and layers, and that corresponds to each line of the Docker file. Which there's something about that just I kind of like. It just the symmetry of it or whatever. I don't know. It's just like, okay, here's a line of the Docker file that will correspond to a layer in the image, and it just it just feels nice. But yeah, you just see the different the commands that are running, and now we should have a new image that is sitting out on. And we do, Nginx. And so then now if we want to actually spin up our Nginx container, oh, shoot. So yeah, Docker run, D, run this in the background. The P flag is where we do our port mapping. So 8000 is the host port, and 80 is the internal port that we identified in that Docker file. And then we're naming our container Nginx container, and this is the image that we want to use. So that's the basic syntax for this particular command.
You can't reverse it, Brian, where it puts the...
Maybe.
Or just hit enter a bunch of times.
Say it again? No, good.
Or just shrink it. Yeah, you could just shrink it to like half screen.
Okay. Yeah, sorry about that. Okay. Is that better? Nah, still not. Yeah.
Yeah, there it goes.
Oh. Oh, good times. All right, and so we see here we've got Nginx container, and running. Yep, and it's running. And so then if we go out to there it is. Man, that's next generation technology. So yeah, it's just that easy to spin up a running container and to specify it in a Docker file, and it's documented. You could put that in source control and make changes as needed. But yeah, not the craziest example in the world, but just kind of illustrates the power of the Docker file and Docker in general.
So I think you said this last time, but I wanted to make sure I understand. So the Docker file, there's some
Yeah.
what you're doing within a container.
For a container, for technically, I guess, an image, which ultimately will generate a container.
And then the goal would be to have Docker files for different functions, like your Nginx versus like your node container or
Yep.
something like that, and then like have them provision themselves separately and then work together. Okay.
Yeah, and so, I mean, so you in theory could bake all that stuff in a single Docker file, but that's probably not the way to do it. One concern per container, so essentially one concern per Docker file, and then you can use something like a Docker Compose to have the different containers work with each other.
So I'll show some of that later.
Yeah.
Yeah.
Yeah. Yeah.
We use it for instance, we develop on a MacBook, but we need to build for RHEL. So we'll use the MacBook as part of our test and build process will be to generate a CentOS image, and then we'll load everything over there, build it all there, test it all there, make sure it's gonna work perfect as well on RHEL.
Right on.
It's still right on our level. So I was gonna ask, and I don't know if you're maybe we'll get into this later, but like a Docker file, is that, I'm trying to connect what you're showing here to like my developer world, like would I, like it's all well and good that you set up Nginx and there's a web server, but you also put in the commands there to like say install git, clone your repo and get all the files and then now you got a server, is that like a common thing?
So I guess it depends what you want to do, right? So I guess in our production environment, we don't necessarily like bake everything into the Docker image, and Puppet has like there's a plugin for Puppet that like goes in there, and we inject stuff into mounted folders, which is not like a normal use case. Like if we update something, like we update some base files, that instead of having to like rebuild the whole image hierarchy, right? So you could do something like that. But I'll show Compose later. Compose, you can kind of, it's a lot faster, I think, to do some of this stuff that way.
That's cool.
Yeah.
Yeah, but yeah, to your point, you can do more than what that Docker file just showed. And I think I do have an example where I do a git clone. So.
I think, we're modifying the mounts. So, like, because we do like our syslog and a bunch of stuff, and then I think there's some stuff gets injected to the mount, and the stuff running on the Docker container expects certain stuff to be in the mount directories, but a lot of that gets added after the fact in Puppet, and Puppet goes through and kicks all the boxes. It kicks all the Docker images when like Puppet has a instance where it's like, oh, I grab these files and I put these Git directories here, then tell Docker Compose to restart everything, and then all the boxes come up and they see those directories exist on those, on the like the fresh host machine is a use case. Yeah, I don't know. That might not be normal, but
Well, if it works.
because if not, you have to like bake the keys into the, like you have the issues, if you want to get to Git, you either have to like you hard code and build your node directory that you're going to run into the image, or you have to bake the keys into the Docker container, into the container, because the container has to go out as root and use that SSH key to do a pull, right? So there's like,
Is that kind of a security issue doing that?
yeah, and then if you accidentally push it to Docker Hub, then now
There it
everybody's got
is.
your Git key.
Very cool.
Yeah.
Oh, yeah, so just rounding out the rest of the reserved words. So args, if you want to pass variables in at build time, you'd use the argument keyword. Labels, just for metadata for your image, so your label, and you provide a key value pair for that. Health check, you can test if your containers are running. And then volume creates a mount point ultimately for your container. And then the rest, user environment, if you want to use environment variables, and on build, stop signal, stuff like that. So recommended practices for Docker files with respect to caching. Usually you want to take advantage of caching where you can. So the way the Docker file works is, as we saw in a couple of these, there was a line saying using cache, and that's great, you know. the idea is that as long as the lines haven't changed, then the cache will be used. But as soon as the cache gets busted on a given line in a Docker file, the rest of the lines will be busted as well, even if they didn't change. And so the idea is that when you order your commands in your Docker file, ideally you'll put your more stable, your longer running stuff towards the top of the Docker file, and your more dynamic elements, your dynamic commands towards the bottom, to where if those bust the cache, the other commands will still use the cache. So this is something to think about. You also want to minimize your layers if you can. Again, each line in the Docker file corresponds to a layer in the image, and I guess each layer has its own overhead. And so with the run command, you can chain multiple commands in a given run command. And so you can, if you have 4 different commands like the app install or app update, app install, nginx, app install node, you can put those on 3 different run commands, and those will be 3 different layers. But if you combine all of them in one, that'll comprise just one layer. And so when you do that, that's great, but then you also have to consider caching as well, because if you've got a bunch of commands in a single run line, if any one of those commands has to change or be removed or anything like that, then that entire run line has to change as well. So the idea is, you minimize layers where you can, but you don't want to jeopardize your caching benefits by doing that. Keep your images small. So we talked about the build context and watching where you put your Docker files, using Docker ignore to ignore the extraneous stuff. Avoid just installing a bunch of unnecessary packages. There's a concept of multi-stage builds, which I don't really have fully formed in my head, but I think the idea, and maybe if one of you, has anybody here used multi-stage builds in a Docker file? No, okay. I think the idea is that, well, like you're saying, a lot of stuff in your development containers you don't necessarily want running on production. And so I think people find themselves managing 2 Docker files at minimum, one for dev, one for production. And I think the idea is with the multi-stage build, you can get the best of both worlds by using your from statement or your from command to start off your build, and that's the development portion, and you'll have a generated image, and then you can also have a different run command that can reference that image, and the idea is that first image, before it finished, it removed all the extraneous stuff, and then within the same Docker file you can reference that image, and I think that's the idea. Like I said, I don't really have an example of it as of yet, but the concept seems kind of cool, and I guess helpful if managing multiple Docker files is kind of a pain for you. And then using small base images. I was using Ubuntu for everything, but I could have used, I guess, Alpine or BusyBox, or there are small, narrowly focused images, because you may not necessarily need everything that an Ubuntu image has. So that's a good way to reduce your image bloat. One concern per container, we kind of talked about that already, just so keep that in mind when you're creating your Docker files, and make sure you're not a lot's going in there, so your container times are fast for boot ups. And one cool trick that I saw was sorting multi-line arguments alphabetically. Again, if you got multiple things happening in your run command, just sorting those alphabetically will help any humans looking at your Docker file to say, hey, did MySQL get installed in this Docker file? Well, we can quickly see that it didn't, because there's nothing between Mercurial and Subversion. It has no bearing whatsoever on the build or the actual container spin up, but it's just good for human sanity. So I want to show one example of caching. So we talked about caching. I want to show one example where I think caching kind of works against you in a Docker file. Oh, shit. Here we go.
We got to do clear again, Brian.
Oh, yeah. Sorry, guys. So again, using Ubuntu, not doing too much. We're just going to essentially clone this repo out in GitHub. And so we'll see an example of that. And this is the repo. Nothing really crazy out here at all. I just want to show how caching can work against you. Let's see. So I guess people that work with Docker files, are there any gotchas or anything like that? To me, the Docker file seems like a really, really cool artifact concept tool, I guess. But nothing's perfect. So are there any kind of pain points in dealing with Docker files? Have you experienced?
Yeah.
Oh, runs are
Unless, well, I don't know if that user changes it, but I think they have to be in the root, like, they have to be in the root group, like in the root wheel.
Okay.
But, yeah.
Let's see. All right. So now we just spin up another container. We'll tunnel into it. And we'll see that test 1 has our artifacts in there. So that's an example of the git clone. We just pulled that down. So that was, cool. Let's see. So now what we want to do is actually out here, we want to create a new file in the repo. Let's see. All right, so we got ZZZ text. And then we will create another image based on the same Docker file. Oops. What's up?
You gotta bounce.
Oh, yeah. There we go. All right. And so here we see we're dutifully using our cache as we should be, And then if we spin up another container, you see we didn't pick up that new file, even though that's what we probably wanted. It's because we were using the cache. So what we can do is we can use the no cache flag when we're building our new image, and that'll pretty much bust out the entire cache. And so we'll ultimately pick up the new file. And so you can do that if there's some way that if you know that your Git repo has new files and you want to get them, that's a way to do it. It's kind of a heavy-handed way though, because you've invalidated the entire cache. And so there are more fine-grained ways of doing it to where I think even if I were to add a comment in the Docker file, one of the lines, which I could try, I think that will only invalidate that line, and then everything else after that will be invalidated, but everything before will still use the cache. Let's see. we see it's in there. Oh, yeah. So yeah, that's the Docker file. Use that to create your images, to create your containers, which is great. But containers are generally used for stateless in a stateless world. But if you want to deal with data and data persistence, containers by default aren't necessarily what you want to be, aren't necessarily suited for that. So, here's an image. Oh, there we go. This is an image that's got 4 layers based on Ubuntu, it's read-only stuff. And then when we spin up a container, we get a thin, read-write layer on top of said image. And that's pretty much the only difference between a container and an image. And the nice thing is, if we spin up other containers from the same image, we won't duplicate this. We'll just have multiple thin read-write layers. And so that's great for storage usage and performance. But with respect to data persistence, it doesn't work because the data doesn't persist. As soon as you remove that container, the data's gone. The more data you put in that thin layer, the bigger your container size is going to get. It's difficult to share that data because that data is tightly coupled to that container. And in order to write to the read-write layer, Docker offers multiple storage drivers. And the performance of those are kind of lacking when you're talking about heavy writes. And so Docker provides a few different ways to get your data out of that container and onto the host machine itself. The first two I'll just mention for completeness. Haven't really done much with them, but I guess temp FS mounts allow the data to reside in the host memory. So outside the container, but over here. And then bind mounts actually will store data on the file system. And so that's actually persistent data. And
I don't think bind's not persistent, is it?
Mm-hmm.
Oh.
Yeah, it's on the file system. Yeah. And non-Docker processes can modify it. And the idea is that you mount data here and you create a connection in the container to the said data out on the file system. But yeah, and I think that was the original data persistence option that Docker had. But the recommended option are volumes. And it's the same deal, the data resides on the host, but in a special Docker area that's managed by Docker. And again, same idea though, you create a mount point in the container that references the data on the host. And so the data can then live outside of the given container's lifecycle. Oh yeah. So yeah, creating a shared location within a Docker directory here. Your volumes can be named or anonymous, but if you create the anonymous volume, you'll get that Mungie alphanumeric thing. And supposedly they're easier to back up data volumes. And the command is simply Docker volume. So the use cases, data persistence, if you want data persistence, volumes are probably your best bet. If you want to share data between containers, volumes are the way to go. And then storing data on remote host, I think you can create a volume on host A and then have containers like host B referencing said volume. I don't think you can do that with bind mounts. I think those are tightly coupled to the host machine.
So they changed it. Mark asked me this question last week or it was like a week or two ago, and it used to be called bind. That was like the command. I think that was the keyword, and that was. We're on Red Hat at work, so they're on Docker 113, and we're on something before that, and now Docker's like 118. And so now everything is called volume, and then you specify the type. So it still refers to the same, like a volume can be a bind or a temp FS or volume.
Oh, okay.
And then they even have a new keyword now called mount that's more verbose, that is the exact same thing volume does, but is more, it's like more specific.
Yeah.
And they're like, well, don't use volume anymore.
Yeah.
But it refers to volumes is kind of like this keyword now, so it's kind of confusing what you talk about, because if you can if you do volume on mine, I built some containers, it like if you're not sharing it automatically does a bind mount and then it goes away.
Oh really?
Yeah, I think so.
Oh,
like
okay. Yep. Yeah, sure.
If it's appropriate for your environment, super handy, enter the
Right.
And this one also, the other one that they had was that because the volume is inside the Docker host, you're not really supposed to reference, you're not supposed to go into like varlib docker
Right.
volume __, but it takes away, now you don't have to worry about whether you're on Mac or Linux because the volume, you just reference the volume name, and as long as that volume's created on that host, then the Docker container doesn't need to know like, oh, I'm actually in the wrong directory and now the context is wrong. So that's another kind of like use case for it. If you have images that are on Unix or OS X, it doesn't matter because the volume, like the location is non-platform agnostic, right?
Okay. So in a couple of slides, talk about a data-only container, and it sounds like that's something similar, but. All right. Well, I think all the examples I have, I'm using the mount keyword, so I guess.
That's the new one.
Yeah. So yeah, in backups and restores, migrations, I haven't done any work with this, but supposedly that's easier to work with your volumes, which is critically important for your persistent data. So, and here are the subcommands that Docker provides you. They're pretty self-explanatory. Create, you can list your volumes. Inspect allows you to see the metadata associated with a given volume. Prune is nice. You can remove all unused volumes in one fell swoop. But they need to be unused. And so any volume that's referenced by any container, whether that container is running or stopped, is not technically unused. So the prune command will ignore that and then remove. If you want to remove a specific volume, you can use that command. And I'm assuming that volume needs to be unused, so there's no orphan references from a container. Terminal time.
Yeah, it'll yell at you if it's referenced.
Yeah.
And I think the one that they have,
God damn it.
they have a demo. It's basically just like a database. You have like Postgres, and you make its volume the data directory, and then you have either that data directory now lives in a volume, and then you have another Docker container that its whole job is just to zip that directory and ship it to S3, or vice versa, like pull down data and unpack it into the directory. Was one of the like these kind of for sidecar, whatever they call them, sidecar processes. That's kind of like that one because it doesn't expose it. It's not exposed to the file system, so you can't see it basically from like, it's not a directory from Linux that you're mounting, right? Like in your, and I don't really know what the use case is other than that.
Yeah, I keep hearing you talk about that, and I'm going back to the data only thing. It's like that abstraction layer between
Yeah.
containers and the actual data. So yeah, I'm spinning up a container here. And honestly, I can't remember what this example is doing, so let's just see what the code does. So we're in Nginx. What's going on here? Default conf. Let's see. Oh, so I'm going to create a copy of this Nginx file. So yeah. Okay, so yeah, this first example, we're not using volumes. We're just in the read-write layer. I've created a copy of the default Nginx configuration file. Let's see.
So the other problem with volumes that is kind of, I don't know why it works this way. There's no way to like create a volume with like data already in it. You have to like create it with the Docker container, and then the Docker container will put the data in the volume, or you create an empty volume. You know, there's no way to say, you can't say like Docker volume create from this directory. And so that kind of, I think, removes some of those, like the use cases, as opposed to like, if you had like a node modules directory, that was like the use case that I told Mark about. That's how I thought they work, is that like, oh, you have one node modules directory, and now you have a, you have multiple node processes. Instead of having 50 copies of Express, you just have one and all share it, but you have to like bring up the container to load the data into the volume before the, it's like, it's funky how it works. I don't know.
All right. So we're going to spin up that container again just to see the data that should still be there. And yeah, the data is still there. But as soon as we destroy the container, we're going to lose that data. So we got that. So if we run another container, I'm going to tunnel in. Yeah, it's gone. So that's just that read-write layer that I mentioned earlier. That's the default way that containers store data. So obviously not all that helpful. So yeah, the Docker creator is going to create a volume. Yeah, and you're saying at this point there's no way to seed the volume with data.
And I think it by default, it copies, if you have a folder called node modules and you mount the volume at the same location, then it copies the data from that directory into there. And if not, it just makes an empty directory.
I got an example.
Yeah.
So now we can see all the volumes on our host system. We just got the one, so that's pretty cool. Let's see. And yeah, this is, like I said, I think all of the examples I have used, I'm using this mount. So the mount flag, I guess, like you said, is more verbose. So create a container. I'm going to open up an interactive terminal, name of the container, volume test. And now these are our mount parameters. So the target is data volume. That's the directory that's going to be on the container. And is oh. Let's see what happens here. Yeah, okay. And so we have data volume there. Oh. So if we use the inspect keyword to inspect volume test a container, looking for the mount information. And so we see destinations data volume here that we specified in our run command. Read write is true, driver is local, and I think that's the default driver for stuff on the local host. You want stuff on remote or NFS or stuff like that. I think there's a way to specify that. Let's see. But if we try to prune, sorry, I think I've got some code screwed up.
So what you're really doing, you're making a volume that's persistent volume only on in the image or exposed underneath on the other.
It persisted in this directory. It's like varlib.
Yeah.
It's inside the Docker directory, and you're not supposed to like touch it.
Yeah.
Supposedly.
Let me jump down here.
I don't. That's what I don't really know. I think maybe it's different if you use one of the remote, like if you're making a volume that talks to a remote like NFS store, then you could somehow pull in the NFS data. I don't know.
Maybe. Yeah, hold on. Sorry, some of my code is jacked up now. What was the point of that? Create a volume, starting the container. Let me just create the second volume. Uh-oh. Oh, shit. Yeah. Let's see here. Something got jacked up. Less. Test. Ah. What happened here? Yeah, we'll try this. Test 2.
It's still mounted on.
Oh, second. God damn it. There it is. Okay. Yeah, I apologize for this, guys. Hopefully that works. And it does. All right, so yeah, now I'm trying to show the data persistence. So in the data volume mount that we have, I'm creating the file message.txt, and I just created that there. Let's see. I'm going to stop the volume test container and remove it. So that container is no longer on the system. And we're going to spin up another container. We're going to mount it to that same volume. And so we're in there. And we should see that message.txt file, and we do. So unlike the read write example where once the container went away, we're able to persist the data outside that container's life cycle. And to Sebastian's point, if we go out and look here on the
So I only know this because OSX, it's on like some weird TTY, like you can't even, well, because they're running inside like a virtual box. So you can't even get to the host data without doing like some really weird magic
Sure.
to kind of get in there.
Yeah, it's pretty limited what I'm able to do. But we can actually see the message text right there. So that's on the host system, and that's a special Docker area for our data. And then, just look at the message. We see the messages out there. So we can spin up other containers, and they can reference that, and all is well. Let's see. So I want to actually create a new file from the host itself. So I think within the same directory, oops. So now we see message.2, message2 text. I don't think there's anything in that file. Let's see. And then nope. start up another container. So now we're in and using CentOS this time. And inside this new container, we should see both message and message2.txt. So, yeah, when I first heard about the volumes, the data being inside this special Docker area on the host, I thought it was like a protected thing, but obviously I'm a non-Docker process and I just added data to that location. And so I don't really know what the benefit is of having it be in a Docker location, but the data's persisted, so that's a plus. Let's see here. And so we could run up, other containers and mount those to the volume, and they can change the data, and obviously non-host processes can change the data, but that may not be what you want, because you get too many things manipulating data, you have to worry about race conditions and just wrong types of manipulations. And so there's a concept of a read-only container. You can spin that up. And so it's the same syntax, except now you add the read-only parameter to your command, and this will spin up a new container, volume test read, mounted to the same volume that we're using.
Yeah. Great.
Oh yeah, what's up, Bryan?
Say you're developing like an app in a local Docker environment. Would it be a bad idea to have like whatever your application directory inside of that volume so that it's mounted to your container and also can account for those changes you make in the data versus like having to like run some type of process inside the container to pull down any changes after you like commit them or something?
So I think, in total grain of salt here, I think that might be a use case for the bind mount.
I would just use bind mount, which I think is like the normal use case. Again, like on the Docker page, they're like, oh, this just removes like machine, and now it's platform agnostic because the mount always exists in the Docker directory, as opposed to on OS X, it's C user or C bin, and Windows doesn't have those directories, so it would be under a different location if you did a bind mount. But I don't think it's maybe worth the extra effort because you know what you're going to deploy to probably, right? I don't know.
So now we're inside this read-only container, and we're going to actually go to the volume of the data volume mount, and we see the two files that already exist. And we're going to try to create our own file in here, and it's going to tell us no because we're read-only. So again, if you have a bunch of containers referencing your volumes, you may not want them all manipulating the data. This is a way to make sure some of your containers only read-only. And the last bit that I want to show are the mount point locations. And this is kind of what Sebastian was talking about. So if we get out of this container. So we're going to create a new volume. It's an empty volume. And we're going to confirm that there are no files on the host, and there aren't. And we're going to spin up a new Ubuntu box where source is the empty volume and the target is the var directory in Ubuntu. And we'll create that. And if we cd into var in our container, you see the usual directory. So then, if we go out to the file system, back on the host, and we're in the actual location of empty volume, before it was empty, now we're going to see pretty much the var directory. And so we took an empty volume and mounted it onto an existing directory with content in the container, and so we were able to populate that volume with data. So yeah, when you were talking about creating the volume with data, at first that was the first thing I thought. It's like, well, but that still isn't the case. You had to create the volume first, then populate it like that.
Yeah, you have to like create it or attach it to a running container to get data into it. It's like really weird.
Right.
I don't know.
So, so then the last example is we're going to spin up another container, and we're going to do a similar mount. Ah, Jesus. And so here, we're inside this container, and it's already looking kind of weird. It's bash for something or the other. And the problem that we have is that I've mounted that existing var, that volume, onto an existing directory. Let's see, pull that back out. So yeah, our source was the empty volume, and we mounted that onto the Etsy directory in our container. And if it was empty, it would have done exactly what it did before. We would have taken the contents of Etsy and put those into the volume on the host. But because the empty volume wasn't empty, we didn't destroy the data in Etsy, we're obscuring it. And so from the container's point of view, that data may as well not be there. So it's kind of throwing all this stuff off. It's tough to tell here, but these directories are not bold. They're just the regular font size. If we go to Etsy, we see we've got backups, cache, host. That's not the normal things we should see in this directory, and it's because we took an existing volume, mounted on top of an existing directory with content. And so the mount location is important when you're using these volumes, to Sebastian's point from earlier. Let's see here. And I think that's it. So just some final tips. Use volumes where possible. The mount location does matter. Read-only volumes to help you avoid race conditions, and prune at regular intervals. Just in the little bit that I was working on this presentation, I was accumulating a bunch of volumes and images and containers as well. So pruning, which you can do for containers and images, is just good hygiene. I'll say definitely for images and containers, definitely want to prune. But for volumes, as you're pruning, just keep in mind that even if you have a quote unquote unused volume with data, there may be value from that data, even though a container isn't currently referencing that. So you don't want to just prune willy-nilly, but yeah, you don't want to clutter up your space either. So with that, I'm going to turn it over to Sebastian. He's going to talk about, I guess, Docker Compose.
Yeah.
Cool.
And networking.
And networking.
And I'm going to go quick. I didn't realize it's already
I know.
there.
Yeah, sorry, guys.
Brian, be taking forever.
That's all I do.
Okay.
Oh, shit, yeah. And this is the data-only container, sorry. So yeah, the idea is that you've got a bunch of containers referencing a volume, but if the location of the data changes, you'll have to change the reference in the containers. Can you hit forward real quick?
Yeah.
And one more time. And so yeah, you create a container, a fourth container, and the whole point of that container is to manage that relationship between the host directory and the data itself. And then these containers just reference this container. And so if any changes happen on the host, make those changes here, and these containers are none the wiser. And so like I said, I don't think that exactly lines up with the stuff you were talking about, but it seems like it's kind of the same boat.
Yeah. I don't know. So,
Yeah.
okay, so I'm going to talk about Docker Compose. I guess it's newer. It's a Python project, but it's part of the Docker ecosystem. It's in their Git repos. And when we first started using Docker at work, we used to have these crazy bash scripts that launch the images actually on the command line. You have to pass all the environment variables in. You have to pass the port exposition on the command line like Brian was doing earlier, like docker run start -p. And so Docker Compose is a single, you can define multiple containers in a single YAML file. So it's basically for defining multi-container applications. So you can do a single container, but a lot of it is like if you have a database and a web server and a logging thing, you can put all of the description of all the containers in one single file. And it creates an isolated Docker environment. So I'll show on the command line, when you use Docker Compose, it only knows about the containers it launched. So just because the machine is running 50 Docker containers, ones that Bryan started or killed containers, when you use the Docker Compose command, it is like only showing you what it launched, not anything else really. It doesn't have control. When you can do like Docker Compose or PS, you only see its containers. And so let's see. So it automates some of the Docker commands, and I'll show that, and it doesn't do everything. There's still times where you have to go back, networking specifically, you have to go back to the actual Docker command for that, right? They didn't do all the process. But it has a lot of like easy one single keyword does like a lot of stuff. And it only, Docker Compose, it only recreates, rebuilds necessary containers. So there's a way that you can have services depend on other services already existing. And Docker's kind of dumb. It just, if it starts the container, it assumes that it's up. But you can say, don't launch the web server until Redis and everything else comes up too. And so depending on the environment, on OS X, it's installed by default with Docker along with Kubernetes for some reason. And then other ones, you can do a curl, but Bryan and I had problems with that. Or no, we had problems with pip install Docker Compose earlier, and we had to use the curl command. So let's see. So this is the same file I'm going to run, and I've kind of put some comments here to kind of tell you what's going on. And so the biggest thing at the top is they have these versions, and part of that is YAML version, and part of it is the Docker Compose version. And they have been like pushing those up really quick. So we're at 2 at work in Docker 1.13. We can't use 3. This is 3, and they're out to 3.7. And each version adds more stuff that you can add into the Compose file, right? So this is, I just did a base version 3, but you can get into some really crazy like swarm stuff. I think you might have to use a higher version number. It won't work. It'll say like, oh, I don't recognize these keys. So they consider at the top, we have this, the top key is they consider as services. So each container that you run is considered a service in Docker Compose. And then on the first one, I'm naming the service web app, and I can actually build the containers if they don't exist. So now I'm saying on this one, build it with the context, right, the standard context, and use the Docker file called Dockerfile. And then I want the image, if it exists, to use that image, and if not, it builds it, right? And you can also pass a build flag, and it'll rebuild everything. And so this case, it's like it's going to build the image if it doesn't exist, and then it's going to tag it web app express. And I'm going to call the container name express1, and I've passed in on the first service here, I actually passed in environment as a key value pair, and I did the port, expose the ports just like you would do in the command. And then the second one, I have a second service called web app 2, and you notice it uses the same image. So what's going to happen is the image is going to get built, and then they're both going to launch with the image that gets built. And I give it a different name, and I'm saying depends on web apps. So don't start this container until the first container in the file starts. And then this one, just to show you, you can just give it an environment file instead of having to specify all the keys directly in the file, which is nice. And there's a hierarchy, which I didn't show here, is that you can have multiple files, and I think it takes the last one as the, it will combine them all, and the keys will overwrite, and I think the one at the bottom is the, considers it to be like the the source of truth.
Sure.
So if you have the same key, so in this, you could have one file that's like, oh, I have node environment, and then, then you have a production thing on top of that, and you can have this kind of like key hierarchy gets passed down. So let's see, Brian, I don't know, how are you switching before? Back to the.
Yeah, it's literally skipping out.
So I'm on Brian's box, so hopefully I won't have to write sudo all the time. And so the other thing is, just like the Docker file, Docker Compose expects the default file to be docker-compose.yaml. So that's the one that it, by default, when you run the Docker Compose commands, that's what it looks for. So I need to go up, right?
Yeah. And one more, I think.
Yeah. Docker prep, and then compose. So, yeah, so we have a, let's see, clear. And so I have this, let's see if this has less on it. So I have this express.environment file. And this one, it has the local port that Express is going to launch with, and it has a message. It has a different message than the other machine. And then I have there's my Docker Compose .yaml is in there, and then my Express inside Express, I have I just have a standard. This one this might do something else. Basically, it's just supposed to print out the message, but I was messing around. Yeah, that one. So it has two routes, and the one route doesn't work. So it'll print out the message from the box, right? It's pretty straightforward, I guess, right? So what we're going to do is we're going to look at. So right now on the machine, there's all this stuff running. So Docker Compose has, right, let's see, has a lot of similar commands, which I have on another slide. But most of these are pretty straightforward, like restart, push-pull, kind of does all the stuff that Docker normally does, and it's really just wrapping the Docker command. So it's just calling the Docker daemon under the hood. But the cool thing is that we can do Docker Compose up. And now, this must be the wrong file. Hold on. Okay, well, that one, that's like a, hold on. See, compose. Oh, yeah. Okay, so this one, I was building a volume on this one, and it expects node modules to be in a volume somewhere. And it just moves the Express directory in, and so NPM's not probably installed on this box, right? So I'm not going to try to do a pull. But I have a different set of containers that has a two file, so I'll use that one instead. Sorry about that. So I'm going to wait. Let's just say I'll go to this folder and I'll run the file just so you can see what up looks like. Yeah, and so this one happens to build Postgres. And so what up's going to do is it's going to bring up all the commands, and they're automatically going to start logging, and it's going to tag the logs. So it like combines all the logs together. So this one, you see it has this Postgres. Postgres is on the name, and that's the name of the container. So if you do a daemon, you can do a daemon here, and it'll put the logs to sleep, right, just like in a normal container. But this one, if you launch multiple containers, it'll show lines for, if I had multiple Postgres containers, they would each have a line in the logs. And there's ways that you can do like Docker compose log, the specific name that you want to see and only view those logs.
That's cool.
And so I'll kill this and I'll do, let's see, clear, right? Compose up dash D. Okay. So, hold on. Docker compose. PS. So, like, you see PS only cares about that Docker compose container. And I think they're all, Docker compose kind of like launches all the stuff together. So I think actually if I bring up another, hold on, I have volume name, compose dash D. So that one built, I basically had that same container, and these were sharing data. They were reading and writing data from each other. So when I show the logs, and you can see this one, it came in and it actually built the images because they weren't built already. So it did compose build or docker compose dash build, did your normal from node, and then it launches the images when they're ready. And you can see that it created both of the containers down here. And when I do, I think this one, I think when you do Docker Compose PS, it actually shows all of the Docker Compose containers. Oh, no, okay, so it's related to that file. So I think that's what we want. I wasn't actually sure if that works. So now Docker Compose, it's reading that Docker Compose file that is supposed to be in the same folder that you're in, right? I think, so I think if I don't know if I get out of here, if it'll still show it. Let's see. Yeah, so that's the other thing. It kind of expects you to be running the command in the folder with a compose file. But all of these containers, they're up there. So you can still kill them and do whatever else you want with them. The other cool thing is that that you can see, I think a couple of my containers died. Volume read died. So if I wanted to kill it, I would have to call docker kill or remove. I would have to kill volume write and then remove both of the containers. But if I go back into the directory, right, which is volume named, and I type docker compose down, it actually stops everything, and it'll clean up all the containers. So then you never really kind of have to go in and prune stuff kind of ever again if you use Docker Compose. And so now it removed the network. This one created like its own kind of network to talk on. And now if I do Docker, the actual Docker command, they've kind of been, I don't think they're here anymore. Yeah, they got cleaned up. So that's nice, so you don't have to kind of hand manage a lot of containers anymore if you put everything in your Docker file. And actually, if you control C out of the daemon logs, it kills stuff, but if you just run Docker Compose, it'll remove the remove containers if they're already stopped.
So when you're composing up or composing down, what happens when you get locked up, if there's something wrong? I mean, does it roll back, or does it leave you in kind of a limbo state?
It'll start the ones that it can start, and it'll say, like, these failed. Like if you have three services in there, and they don't necessarily depend on the others. I think if you have a service that depends on another service and the main service fails to launch, it will not launch the subsequent stuff in there. So I think that's I had like some notes in here. Let me see what else I went through. So that's what I was going to talk about. I have slides. I'm going to get to the networking in a bit. But so Compose builds its own network. So I think they all get I think it's like per Compose file. By default, when you use Docker, there's a host. It's called a host mount and the bind mount. And Linux has host and bind, and everybody else just has bind. And it's like the default, it's just the default network. So if you do Docker network ls, oh, I'm sorry, it's called bridge. So bridge is the default, and then compose default and that network default, those were created by compose. And part of those are still open because Postgres is running on one of them. And the other one is the containers that didn't build and they crashed. So I think if I do docker inspect compose default, it should tell you who's in here. Okay, this one has nobody. Network ls. Let's. So that. Yeah. So I was gonna get to that slide. So this one, you can see when you look at this network, Postgres is still running, and so he got created in his, because of that Docker compose file, he got created in his own network, right? So it's just him. That he's the only container in there, and that got created by default. But I think if you look at bridge, which is the default network inspect bridge. This is where every other container that Bryan launched got stuck in here, because this is the default if you don't create your own networks. So let me go back to the slides and see if I can. I guess. Oh yeah, I have like the little jump out point, right?
I just hit the read at the bottom.
Oh, this one.
Yeah.
Okay,
Yeah.
so yeah.
It'll pop up. Just give it a second.
Okay, yeah, so I probably should have talked about this earlier, right? So these are kind of the main commands, like up brings up all your services. Yeah, in that kind of build definition that I had in the file, that only runs like the first time if the service doesn't exist. And you can pass a flag -- build that will just rebuild everything. And you can pass the same no cache flag, just to tell it like, hey, everything in this file, I want them all rebuilt. And you can bring up, you can do like Docker compose. Most of the Docker compose commands, you can target one of the named services. You can do like Docker compose up just Postgres and not necessarily the other containers in the compose file. So that's like nice too. Like if you just want to build one and you don't want to build, and they have the build command, and they have kill to kill the running services, and then they have logs to attach to the log. So this is basically, that's probably the main, kind of the main 5 for Docker compose. And then I already went to the terminal. And so this is networking. So Docker creates 2 default networks, Bridge, which is a default container network, and then Linux, supposedly some Linux VMs or Linux machines get this one called host that you're not really supposed to do anything with. And you're not supposed to remove these. These are the kind of the standard. And when I first got into Docker, I thought you had to expose ports for everything, right? I was like, if a container has a web app and it needs to talk to Postgres, it needs to expose, Postgres needs to expose 5432, and I want to talk to some other service, it also needs to expose that port, but they can communicate on the same network without exposing anything. So that the containers can talk within themselves. And they also have intra-network automatic DNS resolution. So you don't need to know the IPs that the network gets created. You can define IPv4 and IPv6 addresses, which I don't do, but they get created by default with just like a random localhost 192.168, and then they all get 10. They get some subnet of that. And so you can just use now you can just use the container name, which you gave it in the compose file, which this would work the same way if you used the normal network command. And now I can have now I need to talk to Postgres. I don't actually need to know, I don't need to do localhost. I don't need to know its, so I'll show the demo. All I need to know is the host is the name that I gave it, and it'll do the DNS resolution for you. And the host file isn't really updated. Like you went on the host file, there's nothing in there, but it's taking care of all that behind the scenes. And so the other thing is that the containers can join and leave networks on the fly. except for bridge, which requires a restart. They say that, right? And so that is like you have a running container, where you have a lot of running containers, and you bring up something else, and it's in another network. You can like join it to that other network, or you mistakenly brought up something. I don't really know why you would want to join and leave all the time, but you can do that. And containers can also live in multiple networks. So you could have a container that talks to Postgres and some other service, but then maybe Postgres and that service exist in two entirely separate networks, and they can't talk to each other. But the container in the middle, he can live in multiple networks and talk to everybody for some reason. Again, everybody's on the same host machine. I don't really know what the case is. I don't know. That might play more like when you get into Docker Swarm, possibly. But reading through the docs, I didn't really see like a reason to do that. And so they show you, here's like this is from one of their things. And so they have this like network sandbox and this middle container. He can talk to both. He's on both networks, and he can talk to both machines and can get DNS resolution for both of them. So, and they have a couple commands. You can create new networks, disconnect from networks. You can inspect the network like I already did. You can list them. You can prune unused networks, and you can remove networks. So prune, if there's no containers running in it, it'll just kind of clean them up for you. And so I think this is this is my last demo. So what did I do to get out of here, Brian?
You escape.
Okay. So, okay. Let's see if this likes to wake up. Is it? Oh, there it goes. We used to, and now we use RDS, so we don't. And that's where kind of we had that network. We had a container that it just like zipped up. It went to S3 and it unpacked. We had like a backup. So what happens is the machine, we have Puppet runs all of our machines in our cluster, and some machines come up with nothing on them, and then based on a Puppet file, it says it's the web server, and there was like a Puppet configuration that would turn on, it would pull Compose down, put the Compose files on there and try to run Compose, but nothing existed. And then we had there was another Puppet that went to like S3 and brought some jars down, and one of the containers would unpack everything into a volume, and it would also ship, it would every so often on a cron, I think like in the container, it would ship the logs back up to S3. But I don't really know why it was in a volume. Somebody else did that. Yeah.
Wow.
So, I need to be in Postgres, I think. So let's see what we got here. Okay, so I have Docker file. I have a Docker file that's node, and then I have this other Docker file, which is, let's see. I have another one that just, it just does tail.f because I'm going to go into it and show you that the name resolution works. So let's see here. Let's Docker compose. So there's a way to do, you can do swarm stuff in Compose, but that was like something, I don't use it work, and I don't really have time to go through. It's more complicated. So you can have it, I think like you can tell it like, if you have a swarm cluster to deploy like to these machines in the cluster with these many replicas, And that's something that you can do. It's in the compose documentation, but it doesn't work. It'll tell you like, oh, you're not running in swarm mode, so I'm not gonna make replicas of this box for you. So in this one, sorry, Brian, I forgot I'm in VI on here. Let me see. I think this should work. So in this file, it's also version 3, and now I've said that Postgres lives in the front end network now, and I have another machine that's just, I called it Postgres Connect. It's just a Ubuntu image that I'm gonna ping. I think it's either Express and it tries to talk to Postgres, or it's just an Ubuntu image where I'm just gonna show you that I can ping it. And then networks is its own top level key, and you have to define that network or it won't exist for them to join. So,
How do you embed passwords in your production Postgres?
how do I?
Embed your, how do you pass the passwords, say Postgres password, something like that?
We have, ours is we have environment files that pull them down, and then the Docker Compose would read that environment file. So Puppet goes out to S3 and pulls, it's like a package down onto the machine, and it,
Environment file is just like a key value page, right? So how will you inject passwords in that environment file?
and you just pointed to the environment file?
Yeah.
Yeah,
So do your passwords live in the environment file?
yeah, yeah. Let's see. I think, oh yeah, the node's not on here again. Okay. I forget what's in here. This one's probably the better one to run. And I can show you if you guys want to see it, or I could just end it there. It's up to you guys. Yeah, yeah. Yeah.
I think there's maybe another slide or two in there.
Oh no, I'm taking my mic off.
Let's see. Oh, yeah. So, again, I appreciate you guys coming out. I apologize for the code snafus. Thank you for bearing with me. But for next steps, there were some things we weren't able to cover today. So orchestration is one big one. The CI/CD pipelines, that would be another. Then you see monitoring, logging, troubleshooting, security. Those would be nice topics to see covered for our next Docker presentation. And so here's a list of some of the resources that were used in preparing for this presentation. Those are some of the ones that Sebastian used. And I think that might be it. So. Again, please finish the food. We have to cart out whatever is left. Thank you so much for coming out, and hopefully you guys enjoyed it. So, thank you.